Okay, so guys, we're going to look at the next batch of the questions. But we have a question 3, all right? And the first question, part of question 3, is we need to calculate the following. Now, 3.1, there's an expression there, and we've got numbers, all right? So we're going to calculate. Now, calculate does not mean we must use the calculator. It simply means that we need to basically apply some of the things that we have learned and actually make sure that we show the steps, because in the steps are the marks that we are supposed to get for the question. So for instance, this is 1 mark, all right, and maybe using the calculator will help us to be able to get that 1 mark, but it's better to just show the steps, all right? So let's write it out. It's -3 plus 8 minus 1 minus 7 plus 12 plus 1, right? And let's just, we have how many numbers here? We have even numbers, right? So let's just sort of like piece it apart and get all the -3 plus 8, that gives us 5, right? -1 minus 7 gives us -8, and then plus 12 plus 1 gives us +13. 5 minus 8 is -3, and -3 plus 13 gives us a beautiful answer of 10. Alright, so this is just basically how we can sort of like step by step, come up with the answer, so that people can see that what we've done is what we've done. Okay, and please, 3.1, that was the question. 3.2 says write 0,00125 in scientific notation. Now, scientific notation is a special way of representing very small numbers and very big numbers in such a way that you write it as a product of a number. That number has to be a natural number between 1 and 10. It can be 1, all right, but it cannot be 10, but it has to be 1 or a number between 1 and 10, okay, times 10 to the power of something, all right? So we're going to look at this. This is 0,00125. This is an ordinary number. We need to convert this ordinary number into scientific notation. So what we do is we move the comma that is already there. We move it so that we get a number between 1 and 10. So where do we need to move this comma in order to get a number that's between 1 and 10? We need to move it all the way to this place so that we have 1,25. Maybe someone else would say, but Meniel, can't I move this comma all the way up until here so that I have 2,5? Now remember, if you move the comma up until here, your number that you have is not 2,5, but it is 12,5. So that's why it's important to accommodate the number that you do have so that you do actually write the right number. You can't move the comma here and then expect that the 1 will fall away. No, the 1 still stays there. So you move the comma all the way to the place where you can actually then say for the whole number you have a number between 1 and 10. It can be 1, like I said, but it can't be 10. It has to be 1 or a number between 1 and 10. So if we move the comma here, we need to count how many times we move the comma. That's 1, 2, in between, 3 times. So we have a number 1,25 times now 10, all right, which is always the case. Now, how many times did we move the comma? We moved it 1, 2, 3 times. 3 times. From which side? From the left side. So coming from the left side, we get 1,25 times 10 to the power what? Now, since we moved from the left side, we have 3, all right, 3 times because of how many times we moved, 1, 2, 3. But since we are coming from the left, we put a -3 because this is a very small number. In actual fact, whenever we move from the left-hand side, all right, to the right, then the number that is the exponent of 10 is going to be a negative number. Remember, what did we get the 3? We asked ourselves how many times did we move? 1, 2, 3 in order to get 1,25. all right, times 10 to the power. Then the negative, where does it come from? From the fact that we move from the left all the way to the right to get to 1,25. This is our scientific notation number. Okay, and I hope that's very clear. Then 3.3 says increase 40 in the ratio 5:4. Increase 40 in the ratio 5:4. So whenever we do these types of questions, I like formulating this formula that in order to get the new quantity, NQ stands for new quantity, we take the given quantity, we multiply it by, now since the thing says increase, this ratio 5:4, we can write it as a fraction. But then the ratio, okay, we break it up into the fraction in this way. If the question says increase, all right, then in the numerator, you are actually going to write your big number of the ratio, and then in the denominator, you're going to write your small number of the ratio, because the question says increase. Increase means big number at the top, but had the question said decrease the ratio, decrease 40 in the ratio, then you would still do the new quantity is equal to the given quantity times the fraction, but this time round the small number would be at the top and the big number would be at the bottom. So this is how you go about answering the question had the question said decrease. So since we are saying increase 40 in the ratio, the given number or the given quantity is 40 times, then the fraction, what is the big number in the ratio? It's 5. Right, so that's at the top. What is the small number in the ratio? It's 4, so the small number at the bottom. Then our final answer, if we use the calculator, will give us 50. That is our new what? That is our new quantity, 50. So we've just increased 40 in the ratio 5:4, and we can see that the number 40 increased to become 50. All right, so that's how we know that, okay, really we did increase 40 in that ratio. But like I said, had the question said decrease 40 in the ratio, I'm just gonna check it out, I know it was not asked, but had the question said decrease 40 in the ratio 5:4, we take the new quantity, we take the given quantity, which is 40, multiplied by the fraction. Now the ratio is 5:4, but we said the small number this time will be at the top, the big number at the bottom. Then we'd have 8 times 4, which is 32. So you can see that the new quantity is smaller than the old quantity. So now really and truly, what did we do? We did decrease 40 to become 32. Hopefully that makes sense, and that is also helping us cover the basis for those who are revising, because this is just one singularized question that has been asked, but had it been asked as decreased, then that's what we'd have to take into consideration. Then last but not least, 3.4. 3.4 says a recipe for 20 rolls requires or needs 5 tablespoons of butter. How many tablespoons of butter are needed for 30 rolls? Now this is very important. Just want to kind of highlight something that is very critical and crucial here. Whenever you do a question of this nature, we call this your direct or indirect proportion question. Okay, direct or indirect proportion. So indirect proportion has a certain way to it, and direct proportion has a certain way to it. All right. Direct proportion has to do with the fact that as one quantity increases, you expect that the other quantity will increase. Or if the one quantity decreases, then you expect the other quantity to decrease as well. Indirect proportion is a bit different, because as one quantity increases, the other one will decrease, or vice versa. As one quantity decreases, the other one increases, right? So what we do for direct proportion questions or indirect proportion questions, we need to establish first, is this direct or is this indirect? Because that will affect how we go about answering the question. So first and foremost, a recipe for 20 rolls requires or needs 5 tablespoons of butter. How many tablespoons of butter are needed for 30 rolls? So what we're going to do is we're going to set up a nice table. And in this table, right, we are going to look at the quantities that we have. So the quantities that we have, what are we asked? We are required to find out how many tablespoons of butter. So I'm going to say tablespoons of butter. Okay, I'm just going to use TB for that, tablespoons, and then I'm going to use recipe for rolls. So then I'm going to use R for rolls. Okay, then what are we want how many tablespoons of butter are needed for how many rolls? For 30 rolls. Okay, how many tablespoons for 30 rolls? So we're going to use the variable x. We're going to let x be the number of tablespoons, okay, of butter. Okay, because x is a variable that stands for an unknown that we are still looking for. But we are told that a recipe of 20 rolls, the recipe of 20 rolls requires or needs 5 tablespoons. So we know that 5 tablespoons, that would actually help us make 20 rolls. But we don't know how many tablespoons we would have to get to make 30 rolls. So this table is good. It helps us set up, you know, what it is that we need to actually do here. Okay, so let us proceed. So first and foremost, let x be the number of tablespoons of butter, which is what we want, the unknown variable. Then we know that 20 rolls needs 5 tablespoons. We don't know if how many tablespoons does 30 rolls need. But now let's ask ourselves a question here. What's happening to the rolls here? The rolls are decreasing. From 30 to 20, we are decreasing. What are we expecting with the tablespoons? If I require 5 tablespoons to make 20 rolls, what am I expecting will be the number of tablespoons that I will require to make 30 rolls. So I'm expecting that I'll have more rolls. With more rolls, I'm going to need more tablespoons to make more rolls. So what I can expect then is that from this will be a bigger number, this will be a smaller number, just like this is a bigger number and this is a smaller number. So this quantity of tablespoons decreases, just like this quantity of rolls decreases. So as this decreases, this one decreases. As this increases, this one increases. So this is a typical example of direct proportion. Seeing as that is the case, when I set up my equation, I'm going to set it up in this way. X over 5 is equal to 30 over 20. Alright? Because of direct proportion. If it was indirect, I wouldn't set it up as two fractions like this. And I'm going to look at an example so that you can see the distinction between the two. So I have x over 5 is equal to 30 over 20 because it's direct proportion. So whenever it's direct proportion, please make sure that your unknown first and foremost is on the top left hand corner. This is for both direct or indirect proportion. Whatever you want to find, write it at the top at the left. X over 5 is equal to 30 over 20. Then I solve for x. I'm going to multiply both sides by 5. Right? Why do I multiply both sides by 5 over 1? Because 5 here was in the denominator, there's a 5 in there. So these two will cancel, we'll leave with x. And then that means 30 times 5 over 20. Okay, then you can just use your calculator and say 30 times 5 divided by 20. You're going to get 7,5. Now 7,5 what? Those will be 7,5 tablespoons. Okay, and that's basically how you would go about getting that. So that's 3.4, guys. That's 3.4. That's how we go about answering 3.4. It's a direct proportion question. It's just best to set up the equation like this so that you can be able to maneuver very swiftly in answering the question. Hope that makes sense and that it was helpful.